Okay, so we're going to have a look at the two parts of your GCSE core practical on electrolysis. So the first one of these is having a look at electrolysing copper sulfate using copper electrodes, and we're going to have a look at the mass change, or measure the mass change of the electrodes as we go. So you can follow your instruction sheet with me, and we'll work through the various parts to set up the experiment, and then we can use some data that I've generated previously in order to have a look at the questions and the follow-up work there. So for method one, using our copper electrodes. So in our general setup, so we have our copper electrodes here. We're going to use a glass beaker in order to be our cell, so that's going to contain our copper sulfate. We've got our multimeter here so that we can measure the current that we're applying, and we've got our power pack to set our voltage that we're needing and to adjust the current as well as we're going. Okay, so the idea is that we're going to apply 4 different currents here, and we're going to measure the mass of the electrodes at the start and the mass of the electrodes at the end, and see if we can spot any patterns there. So first thing we need to do then is to take our copper electrodes and give them a good old clean with some sandpaper to make sure we've got any oxide layers removed there. We need to label one of them as the anode and one as the cathode. So we'll just mark an A on that one for the anode, and this one's been used before, but we'll just go over the C that we've got that. We then need to record the mass of each of these. So we pop those over onto the balance, and then we can write down the mass, and then we repeat that for the other one as well. So those are our starting masses of our electrodes. We then need to half fill our beaker with the copper sulfate solution. So pour our copper sulfate in there, it's lovely blue colour. And then we need to set up the circuit as it's shown in the diagram. So we've folded over the ends of the copper here purely because then we can use our crocodile clips as pegs. We want to make sure that the electrodes don't actually touch each other, otherwise we're going to have a short circuit, so we kind of peg them onto the outside. So I'm going to put my crocodile clip onto this one here, and this is going to go into here. And then this one is going to come, oops, sorry, that one goes into the bottom there. And this is going to come and clip onto that side there. Okay, so that is our circuit set up there. So we want to switch the power on, and then we want to adjust so that the reading on the ammeter there is going to be 0.2 amps. Okay, so we've now got a current of 0.2 amps running. We've got the stop clock running there as well, and this is going to be applied for 20 minutes. So I will pause the recording now, and then we can fast forward once our 20 minutes has finished. Okay, so if I stop the stop clock there now, so 20 minutes has elapsed there, so we now need to switch our power off. We need to disconnect our crocodile clips there, and we need to go and first of all rinse our electrodes with distilled water. Okay, so that's our cathode rinsed. Now the next thing we're going to do is dunk these into acetone. Now acetone is what you have in nail varnish remover, and if you've ever used that, you might notice that it feels rather cold when you've got it on your skin. So if your skin is feeling cold, this is a bit of extra chemistry here. If your skin is feeling cold, that's because it's taking the energy from your skin to allow it to evaporate. So it's got a nice low boiling point, much lower than the water in the copper sulfate and the water, obviously the distilled water. And so by dunking it in the acetone, we rinse off the water, and then the acetone itself dissolves nicely. I can even feel the coldness on the electrode there. And then once we've done that, it's nice and dry now, and we go and record our final mass. And I will show you in a second the results table, and so you can see all the different masses once I've recorded all of these results. Okay, so just having a look at actually the nature of the copper electrodes itself, it's quite interesting to see what's going on with them. If you have a look here, I don't know how easy it is to actually see there, but the surface of this electrode is quite roughened up as well, and the surface of this one, it's still a little bit wet there. Let me put it in the acetone then. Is quite smoothed down. So once you've had a look at the mass changes of each of the electrodes, you might like to think about why it is that one's all nice and rough now and one's all nice and smooth. So we've got our cathode over here in my left hand here that is rough, and we've got our anode here that is all smooth, so we can think about that. So our second experiment that we need to do is again electrolyzing copper sulfate solution, but this time we are going to use graphite electrodes. So I've got my graphite electrodes here on my little perspex holder. So this is to hold them separately apart in our copper sulfate solution. So we can pop those in there, and the holder will just rest onto the top. Now this time we're going to be applying our current, and this is qualitative this time as well, so we're not going to be worrying about the masses, we're just going to be having a look at the electrodes. Let me put those in so they're not falling over. Okay, so I am going to switch on the power pack here, and then we're going to have a look at what is happening in the electrodes as we go. Okay, so it looks like this one is playing ball better than the last one. So we can see as I turn the voltage up there, we're increasing the current that we have applied. So I think we'll go for about 0.4 amps. Ooh. There we go, that's close enough. Okay, so if I now bring this up here, see if you can see what's going on. So if we're looking carefully into our solution there, can we see on the right hand side very clear effervescence happening? So it's fizzing around like crazy. Remember, in terms of exam observations, if you need to give 2 observations, don't say effervescence and fizzing, otherwise you might as well have just written one of those words twice. So we've got loads of fizzing going on at the right hand electrode. So you need to think in terms of the ions that you've got present in the solution. So we've got aqueous copper sulfate. So our copper sulfate gives us a copper 2 plus ions and SO14 minus ions. But remember, because it's aqueous, we've also got the H plus ions and the OH minus ions from the water. So we can have a think about what might be going on, which ions might be reacting, and what gas we might be produced there. And then it's harder to see just looking here what's going on at the other electrode. But if I then disconnect this and lift the electrodes out, hopefully we can see. Yes, so if you have a look at the left-hand electrode there, we can see now that it's turned a kind of browny pinky colour, however you want to describe that. So what is that going to be on our graphite electrode, and which of the ions that were present in the solution are going to have given rise to that reaction there?